All right, we are now streaming. Well, we're recording, and we are streaming now. So welcome. We are going to be doing a little adventure with Async Rust, and so we've got this program here that Claude helped me build. Now I haven't reviewed this that much, so I'm basically reviewing these things for the first time. Let's see what Claude made for us now and see whether I'm able to get this thing correct. Let's see how many parts of this that I'm able to get correct. So let's look at here. We've got hello async, spawn, join, channels, select streams, async locks, manual future. Okay, that'll probably be interesting. And we've got some other stuff there. Okay, so let's do hello async. Actually, hold on. There's an easier way to do this. What is it? Zellage. Now, how come? Okay, I need to resize this. This is this is cutting off part of the screen. Okay, there we go. I think that's much better, but I do need to zoom in on this so that it's hopefully readable to all of you who might be watching. Oh, and then also okay, yeah, we've got the stream going here. There we go. So now that we have our beautiful terminal here, let's do a new pane. And so in here, we're going to do helix. Okay, and we've got our hello async thing. We've got the question right here, and we've got the answer right here. I want to just double check and make sure. I want to make sure that we've got the font size working properly here. It could probably use a little bit more. Okay, let's see. That's pretty good. That's pretty good. So we're gonna go, so as we can see, we've got all of these different things here that we're gonna be possibly getting to on our adventure. I don't know. I do have an appointment later this afternoon, but we're gonna get through as many of them as we can. So without further ado, let's do the question. The first rung. Slow greet is synchronous and the runtime is missing. Where's slow greet? It's over here. Our goals are number 1, to turn slow greet into an async function that uses Tokyo time sleep. And we're going to do that instead of stood thread sleep. Okay. And the second goal is we're going to turn the main function into a Tokyo entry point and .await the future. We're going to run this with cargo run -p hello async -bin q0. We're allowing some unused stuff here. We're using stood time duration. We have our slow greet function here, where we take a string slice and return an owned string. We've got stood thread sleep for the duration of 100 milliseconds, so 0.1 seconds. And then we format hello and then the name here. So that's the string that we end up returning. We've got our main function here. where we declare a variable message, and we do that by calling the slow greet function, which we defined here, and passing in this string slice world, and then we print that message. So on its own, this should work. So let's see. Cargo run -p hello async, then q0. Hello world. Okay. There we go. There we go. We've got the hello thing and then world. Okay, that works. So it works as is in this synchronous model. What we need to do is to make it async. So turn slow greet into an async function that uses Tokyo time sleep. So that's pretty much giving us what we need. So Tokyo time sleep. So we're going to change this. Sleep. Actually, hold on. There's probably a more idiomatic way to do this. Let's do use Tokyo time. And then, I mean, just with this, will it make us do a cargo.toml thing? It panicked. There's no reactor running. Must be called in the context. Okay, now we're already running into some trouble. So let's time sleep, and then well, I mean, let's do this. Let's go to the documentation for Tokyo. First of all, can you even see this? Let me add you all to this screen journey here. Okay, here we go. We've got you joining us. Blah 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 blah. Okay, yeah, so we're gonna need this in front of our main function. And what else are we gonna need? We're gonna need make that async. We're gonna need to make this async. We're probably gonna need something in front of this, some attribute. Let me get this over here. That way y'all can see what I'm doing here. OBS has been giving me trouble today, so. We don't necessarily need anything. Future cannot be formatted with the default formatter. Let's see. Yeah, we're off to a rough start, folks. Future string does not implement stood function display. Oh. What if we were to await? What if we were to await that? Well, we've still got some nonsense here. So let's see. Okay, yeah, we're probably going to want to await that too. So let's do dot await. Oh wow. Did that solve our issue? Oh my goodness. What the? This is wild. Okay. That was what... It wasn't even suggesting to use the await. Like, we had to figure that out looking at this error message here. Let me move this out of the way. We had to look at this thing here and say, okay, the compiler is saying impl future output equals string, which is what the actual return type is under the hood. Since we made this an async function, it returns a future of a string and not purely a string. So we had to look at this error and say, okay, obviously future of a string, okay, that's not something that implements display, and so when we use the result of calling that async function, which returns the future, and we haven't awaited it yet, then yeah, we'd have to use debug formatting or something. So we had to look at that and say, okay, what is actually the solution here? And it turns out the solution in that instance is to await the future. Okay? So that's... Yeah, obviously I am rusty on this, pun intended. So we awaited it on both this part and on this part. Now, what if we were to get rid of the await call to await here? Okay, would it still work? Okay. Wait. Okay, time sleep. So we sleep for that time period. Does this return a future? Because it comes from tok.io. I want to find out. Does it return a future? Let's do tok.io. Let's search up. First of all, let's increase the font for all of you. There we go. Time sleep. Okay. Available on crate feature time only. Future returned by sleep and sleep until. Okay, so it does return. Wait a minute. Is that the struct or the tok.io times sleep? Okay, sleep duration from milliseconds. Okay. Wait a minute. Okay, we're still using stood time duration. Let's do. Let's change that. And then let's get rid of this. And now we'll write the changes. Okay, this should still compile. Fingers crossed. Okay, hello world. Okay, we've got that. So we've got the async function here, slow greet. That still feels pretty fast. Let's increase this here. Okay, let's do 10 seconds. Wait, what? Hold on. From milliseconds, so 1, 2, 3. Damn it, I keep forgetting this stupid thing. Let's move that out of the way. What if... never mind. Anyway, let's just keep going. So, turn slow into async function that uses sleep. Okay, we've done that. Okay. Now we turn the main function into a Tokyo entry point and await the future. Okay, we did that, I believe. So let's see whether Claude, let's see how this compares to Claude's answer for us here. Okay, so this is Claude's solution. Use stood, time, duration. Wait, what? Why are you still using stood time duration? You don't need to... Well, is there any benefit to using the async version? Let's see. Is there any benefit to using the async version? In Rust. Okay, so Leo says, yes, there's a significant benefit to using the asynchronous version of duration, such as Tokyo time sleep. I didn't ask about Tokyo time sleep. I asked about duration. Wait, is it? What's the exact thing? Let's ask the correct question. Come on, Leo. No, there's no difference. Simply a re-export of this. You can use one interchangeably with the other. But I thought this one showed a... Hold on, this is the sleep function. Okay, that one's async. Now let's do Tokyo time duration. Structs. Re-export. Oh, it re-exports. Okay. That's what it is. It re-exports duration. So there's our answer for why Claude's answer still uses the stood time duration thingy here. So let's look at what they do next. Okay, so they have the async this little async thing here in front of both of these functions, both main and slow greet. And they await in both places here and here. Okay, so that's interesting. So Tokyo times sleep. So we await that. Oh, that's probably why when I was running it in here, okay, it's like boom, even though I had set it to like 10 seconds and it was just doing it instantly. What if I were to await the sleep? Maybe it would wait on returning that. Wait a minute. Honestly, I'm just an idiot with this stuff. Okay, so let's instead do A0. Okay, that one was still pretty hard to tell. So let's add an extra 0 there to make it a full second. Okay, that one had a noticeable impact. Okay, just to make sure it wasn't a one-off thing, let's add another 0 to it. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm terrible at keeping accurate time like that. But okay, that was definitely an impact. So just changing that await within the slow greet function when we had Tokyo times sleep, awaiting that apparently forced it to wait before doing the return of this. So, and wait a minute, if we think about it, Rust futures are lazy. So that means that if the compiler can get away with having the code not run at all when it's returning to future, it's like it won't run at all in general. And so with this, does the result of this computation end up actually impacting what gets returned? No. It's purely here to cause a delay. The format value, we've got the hello here, we've got the name, which is a string that's passed through as an argument. And so the function would return the same value regardless of what this one has going on here. And so it could get away with returning early if we don't await it, apparently. And so we've got that covered. The signature looks pretty much the same. We've got Tokyo main as an attribute thingy here. And yeah, we've got the call to await. So that's our first one there. Okay, let's see how much I'm doing on time. Okay, we've got, I don't know, maybe 30 minutes or something. Or depending on how long this storm outside lasts, I might be here for a bit longer, who knows. But hopefully I'm able and free to go. So we've gone through the first one here. Let's continue on to the second one. So we're going to do file picker 01. We're going to go to question 1. Question 1, concurrent tasks. 3 independent jobs each take about 500 milliseconds. Run sequentially the program. Okay, run sequentially, the program takes about 1500 milliseconds. Make them run concurrently, so wall clock drops to about 500 milliseconds. Goal, spawn each slow job onto the runtime with Tokyo spawn. Await all 3 join handles and print their results. Run with cargo run -p task bin q1. Okay. So let's look at what we've got currently. We've got an import here of stood, time, duration, and instant. And then next we've got a slow job function. We take a U32, return a U32. We go to sleep. Sleep is important. Make sure to get your sleep at night. But not right now. Keep watching. But do drink your water. So duration from milliseconds, 500. And then we do a dot await right there. And then we return the square. How do we prevent overflows? I don't think this one is capable of accounting for overflows. But anyway, that's besides the point. We're focusing on async right now. So we've got toke.io main, async function main. We have let's start equals instant.now, so basically creating a timestamp for that. To do replace this sequential code with 3 concurrent spawns. We have 3 variables A, B, and C. They each make a call to slow job, and they're each awaited. Yeah, this is going to operate sequentially, it looks like. Results ABC, elapsed equals start.elapsed. Okay, this should compile as is before I interrupt what's going on here. So let's test that and find out. So let's do Q1, not D1, Q1. There we go. If I can type no binary target Q1. Okay, I have to edit this. Okay. I feel like that one definitely had a slowdown. Let's make it a little bit more noticeable. Let's do do 1,000 milliseconds, so a full second, and it should go for each of these in order, sequentially. Okay, 1, 2, 3, boom. Okay. So when we have this slow job and it's sleeping for 1,000 milliseconds, and we await that before returning the square, and we have 1, 2, 3 squared equals 1, 4, and 9. That makes sense. And we've got slightly over 3 seconds that's left. Okay, so this makes sense so far. What we need to check now is, okay, this appears to be adding on top of each other. So like each of these calls to slow job.await, we add 1 second, and then another second after that, and then another second after that. And even though we're calling an async function and we're doing it within an async main function, it still seems to be basically being done as if it's one on top of the other. One, then the next, and the next, and the next. Now, what if we can really make this more idiomatic in asynchronous context by having it so that these delays are not interfering with each other. So maybe instead of 3 seconds, we can cut it down to 1 second. Let's find out. So spawn each slow job onto the runtime with toke.io spawn. Okay. I wonder Now I'm a rebel, so I'm gonna try something completely off script here. So I'm gonna do these, and then I'm gonna interrupt myself. So future. Okay. So what if we do? Okay, let's get rid of that. So let's do a.await, b.await, c.await. Okay, okay. Future doesn't implement display. Oh, okay, yes, because we've got to update that. Wow, okay, all the compiler errors went away. Let's try this again. Okay, 1, 2, 3. That was still 3 seconds. So my solution here, if you want to call it that, did not work. So we weren't able to get out of it like that. So we're gonna have to actually use Tokio spawn. Await all 3 join handles and print the results. Okay, so we're gonna be using Tokio.join. Wait, hold on. Let's bring this back up here. And then join. Waits on multiple concurrent branches. Yeah, I want to go to Tokio tasks. Okay, so we're here in the Tokio docs. Okay, this is probably where we're at. Okay. Tokio spawn. Let handle equals Tokio spawn. Async, do some work. Equals handle.await.unwrap. I remember there being a join function. Like there's... You know what? Let me just ask Leo, okay? Make a Rust Tokio function that does 3 tasks and joins them. Okay, let's have the AI do it for us, because navigating the docs is going to take too much time. So to execute 3 concurrent tasks and join the results in Rust using Tokio, you can use the join macro to complete the same task. Ideal for a known fixed number of tasks, as it avoids the overhead of spawning separate OS threads and ensures a fair polling order. So we've got these three things here, and they're all basically the same. Tokyo join, and they're all async functions. So this is basically exactly what we're looking at. Okay, so instead of this, whatever this is, we've got to let me get this out of the way. So based on what we learned from that, we can have A, B, C. And we're going to be using Tokyo join. And then we're going to be printing these. Okay, and this should be conceptually identical to the example that Leo gave us. So let's write our changes. I don't see any errors right now from that. So let's try it. Okay, 1, 2, boom! Okay, that is fundamentally different. See that? We have 1 second elapsed, and we've got all of the results here. Okay, so now we're seeing some real asynchronous action here. That is awesome. So what do we have going on here? We've got these variables that we declare. And what are these? These are futures. See that here? It has the type annotations that are sort of presented to us in this grayed out version, since we haven't put them in there explicitly. But the IDE is doing that for us. And so it says A, B, and C are each something that implements future output equals U32. So all three of these variables, A, B, and C, they are not U32s, they are futures of U32s, which are lazy, okay? So these don't actually get evaluated until we await them, which happens with this call to the join macro, apparently. Wow. So that was pretty cool. That was pretty cool. So we still have a little bit of time. Oh, I forgot. We need to check what Claude has for us for this solution. So let me go to that, 0, 1. Stood time, okay. So we've still got this stood time thing going on here. We've got the async function here, slow job, Tokyo time, sleep, duration, 500, okay. That seems fairly normal. Oh my goodness, they use unwrap 3 times. Oh yeah, it's because I'm a rebel and I didn't follow the instructions. Okay, I didn't use the Tokyo spawn thing. I found a better way. No, I don't know whether it's better or not, but we certainly found a different way. Now let's see. So this was the one with my version. Let's see how Claude's version compares. Okay. What? Oh. Haha. We're not comparing apples to apples yet, folks. So let's change that to a full second. Just like the one that was for me, okay? Okay, so Claude's version does slightly worse, although that's probably still within the margin for error, so See, okay, and that time it did slightly better than me. So yeah, it's basically neck and neck as far as performance between Claude's version and my version. And so looking further into this code written by Claude for Claude's version, we've got our main function. Okay, we've got the timekeeping stuff with the start and then the elapsed here. And so what do? We have Tokyo spawn for each of these, h1, h2, and h3. And then we call .await, .unwrap for each of these. This one didn't even join it. I thought it was saying that we were supposed to do join. Was I hallucinating that? Global spawn each slow job onto runtime with Tokyo spawn. Await all 3 join handles and print the results. Okay, so it had join handles. I think that's what got me confused. Now, does Tokyo spawn return a join handle? Let's check that. Okay, Tokyo task spawn. I only missed the most important function in the module. It takes an async block or other feature and creates a new task to run that work concurrently. Like stood thread spawn, task spawn returns a join handle. Okay, so there we have it. It returns a join handle after all. We can put that away. And we are basically getting close to the end of this stream, so we're gonna have to wrap it up. But the weather is also starting to get nice, so that's a reason for me to get out anyway. But love you all, and you have a fantastic day. Let's see.